Engineers have had to develop very clever algorithms and ways of trying to store information in quantum computer memory and build the memory such that it's resilient to errors. The world of technology is advancing faster than ever before, with groundbreaking discoveries being made in fields once thought to be purely theoretical. Among these fields, quantum computing stands out as one of the most transformative and enigmatic technologies humanity has ever developed. Now, Brian Cox, the celebrated physicist and science communicator, has shed light on a recent development in quantum computing that has left even the most seasoned scientists and technologists in a state of alarm. At the heart of this revelation is Google, a company that has been at the forefront of quantum computing research. Their new quantum chip has reportedly surpassed every benchmark previously imagined, achieving capabilities that until now existed only in the realm of science fiction. But this isn't just a story about technological progress, it's about the profound implications of this discovery, implications that could affect our privacy, our security, and even our fundamental understanding of reality itself. To grasp the significance of this discovery, let's first delve into what quantum computing actually is and how it differs from the classical computers we use today. Traditional computers, no matter how advanced, operate using binary code, a series of ones and zeros that represent information. Each bit in a classical computer is either a 1 or a 0, like a switch that's either on or off. These bits are the building blocks of all the digital technology we rely on, from smartphones to supercomputers. Quantum computers, however, operate on an entirely different principle. Instead of bits, they use quantum bits, or qubits. Qubits can exist not only as a 1 or a 0 but also in a superposition of both states simultaneously. This means that a single qubit can represent far more information than a classical bit. When multiple qubits are entangled, a unique quantum phenomenon where particles become interconnected, they can perform calculations at speeds that are orders of magnitude faster than the most powerful classical computers. This might sound abstract, but the practical implications are staggering. Quantum computers have the potential to revolutionize industries ranging from medicine to finance to artificial intelligence. They could solve problems that would take classical computers millions of years to compute, such as simulating molecular interactions for drug discovery or optimizing complex logistical networks. However, as Brian Cox has pointed out, there's a darker side to this technology that cannot be ignored. The power of quantum computing lies in its ability to break through computational barriers that have long safeguarded our digital infrastructure. Encryption, the backbone of modern cybersecurity, relies on the mathematical difficulty of certain problems, such as factoring large numbers into primes. Classical computers struggle with these problems, which is why encryption is so effective. But a sufficiently advanced quantum computer could solve these problems in seconds, rendering current encryption methods obsolete. This is where Google's new quantum chip comes into play. According to reports, this chip represents a monumental leap forward in quantum computing capability. Google has already demonstrated quantum supremacy, the point at which a quantum computer can perform a calculation that is practically impossible for a classical computer. Now, with this new chip, they have entered uncharted territory. What makes this chip so extraordinary, and so concerning, is its sheer power. Early quantum computers were limited by the number of qubits they could effectively utilize, as maintaining quantum coherence and minimizing error rates posed significant technical challenges. But Google's chip has reportedly overcome many of these limitations, achieving a level of stability and scalability that was previously thought to be decades away. The implications are profound. For one, this breakthrough could mark the end of online security as we know it. Most encryption protocols, such as RSA and AES, are based on mathematical problems that are virtually impossible for classical computers to solve within a reasonable time frame. A quantum computer, however, could crack these codes almost instantaneously. This means that everything from personal emails to financial transactions to government communications could be exposed to unprecedented levels of vulnerability. But the risks go beyond cybersecurity. As Brian Cox has emphasized, quantum computing challenges our very understanding of reality. At the heart of quantum mechanics are principles that defy classical intuition, such as superposition, entanglement, and the observer effect. These phenomena are not just abstract concepts, they are the foundation of how quantum computers operate. By harnessing these principles, we are essentially tapping into the fundamental fabric of the universe. But in doing so, we may be opening Pandora's box. One of the most unsettling aspects of quantum computing is its potential to simulate reality itself. In recent years, scientists have speculated that if quantum computers become powerful enough, they could be used to create highly detailed simulations of the universe. This raises profound philosophical questions. Simulate reality. How can we be sure that our own reality isn't a simulation? This idea, often referred to as the simulation hypothesis, has been debated by philosophers and physicists alike, but the advent of advanced quantum computing brings it into sharper focus. Moreover, the ability to simulate reality could have unforeseen consequences for humanity's future. Imagine a world where quantum simulations are used to predict human behavior with near-perfect accuracy. Governments and corporations could potentially use this technology to manipulate individuals and populations on an unprecedented scale. Privacy, already a scarce commodity in the digital age, could become a thing of the past. The ethical implications of quantum computing are equally daunting. Who should have access to this technology? How do we ensure that it is used responsibly? And what happens if it falls into the wrong hands? These are questions that policymakers, scientists, and ethicists must grapple with as we stand on the brink of a quantum revolution. Despite these challenges, it's important to recognize that quantum computing also holds immense promise. If harnessed responsibly, it could usher in a new era of scientific discovery and technological innovation. For example, quantum computers could revolutionize our understanding of the natural world, from the behavior of subatomic particles to the dynamics of complex ecosystems. They could also enable breakthroughs in fields such as renewable energy, material science, and quantum biology. In medicine, quantum computing could accelerate the development of new treatments and therapies by allowing researchers to simulate molecular interactions with unprecedented precision. This could lead to the discovery of cures for diseases that have long eluded scientists. In agriculture, quantum computers could optimize food production and supply chains, helping to address global hunger and food security. Even in space exploration, quantum computing could play a pivotal role. By solving complex equations that describe the behavior of celestial bodies, quantum computers could help us navigate the cosmos more effectively. They could also enable the development of advanced propulsion systems and materials, bringing humanity closer to realizing its dreams of interstellar travel. As Brian Cox has pointed out, the challenge lies in balancing the risks and rewards of this technology. Quantum computing is not inherently good or evil, it is a tool, and its impact on society will depend on how we choose to use it. To ensure that it benefits humanity as a whole, we must approach it with a sense of responsibility and foresight. This means investing in education and research to build a workforce capable of understanding and managing quantum technologies. It means fostering international collaboration to prevent a quantum arms race and to establish ethical guidelines for its use. And it means engaging the public in a dialogue about the implications of quantum computing so that we can make informed decisions about our collective future. Google's new quantum chip is a wake-up call, a reminder that the future is arriving faster than we might expect. As we stand at the threshold of a new era, we must confront the challenges and opportunities of quantum computing with courage, curiosity, and a commitment to the greater good. The decisions we make today will shape the world of tomorrow, and the stakes could not be higher. Quantum computing's potential for unparalleled benefits and its alarming risks both stem from the same source, the unprecedented computational power that taps into the very mechanics of the universe. As scientists, technologists, and governments begin to fully comprehend what Google's new quantum chip represents, the discussion shifts from a mere technological milestone to a question of responsibility, ethics, and humanity's ability to manage the tools we create. Let us first explore the challenges of harnessing quantum power in the current technological landscape. For decades, the bottleneck for technological advancement has been computation. Many real-world problems, such as modeling the Earth's climate, deciphering the genome, or simulating entire economies, are staggeringly complex. Traditional computers have struggled to solve them due to computational limits. While advances like GPUs and supercomputers have provided incremental improvements, quantum computing represents a paradigm shift. Yet, the same power that allows quantum computers to simulate biological systems or create predictive economic models poses existential risks when applied recklessly. One of the most immediate concerns is the threat quantum computing poses to privacy. Encryption protocols, which protect sensitive data worldwide, are built on the principle that certain mathematical problems, like factoring large prime numbers, are practically impossible for classical computers to solve. Quantum computers break this assumption. Google's recent quantum chip demonstrates the ability to surpass the computational barriers that underpin most modern cryptographic systems. Brian Cox has highlighted the alarming speed at which these systems could become obsolete. The implication is staggering. Financial institutions, healthcare providers, and governments that rely on current encryption standards are now vulnerable to data breaches at an unprecedented scale. Sensitive information, from financial transactions to classified state secrets, could be laid bare. This isn't a hypothetical future, the implications are already shaping global strategies. In response, nations are racing to develop quantum-resistant cryptographic protocols and new algorithms. Designed to withstand the power of quantum decryption, quantum-safe cryptography is a step in the right direction. However, the development and global implementation of these security measures will take years, if not decades. During this transition period, the world will remain at risk of exploitation by those who gain quantum supremacy. And then there's the ethical question: should any entity, corporate or governmental, wield the capability to access and potentially manipulate the vast majority of the world's encrypted information? In the wrong hands, a sufficiently advanced quantum computer could destabilize global economies, undermine democratic institutions, and violate individual privacy on a scale previously unimaginable. But privacy isn't the only concern. Let's delve into the broader implications of quantum computing in artificial intelligence. AI is already transforming industries, from automating tasks to creating personalized user experiences. With quantum computing, AI systems can be trained on datasets so vast and complex that classical systems cannot even begin to process them. This opens the door to machines with capabilities beyond human understanding, machines capable of learning, adapting, and evolving at speeds far surpassing human comprehension. Imagine an AI system equipped with a quantum processor. It could analyze patterns across billions of data points in milliseconds, predicting outcomes with near-perfect accuracy. Such systems could revolutionize fields like healthcare, allowing for early detection of diseases or personalized treatments. But the same technology could also be used to manipulate human behavior, predict societal trends, and influence elections. The ethical lines between innovation and exploitation could blur beyond recognition. This brings us to the question of autonomy. With AI powered by quantum computing, decisions once made by humans could increasingly be delegated to machines. On the surface, this seems beneficial. Machines are less prone to bias and error than humans. But what happens when the systems making these decisions become so complex that even their creators don't fully understand how they work? Who is accountable when an AI system makes a mistake or, worse, deliberately acts against human interests? The possibilities of autonomous quantum-enhanced systems also raise concerns in military applications. Quantum computing could be the key to developing advanced autonomous weapons capable of making split-second decisions on the battlefield without human intervention. These systems could analyze enemy movements, predict strategies, and deploy countermeasures faster than any human general. But in doing so, they could also remove the human element from decisions of life and death, leading to conflicts where outcomes are determined by algorithms rather than diplomacy or morality. The implications don't stop at AI and cryptography. Another area profoundly affected by quantum computing is our understanding of physics and the universe itself. One of the most profound capabilities of quantum computers is their ability to simulate quantum systems. These simulations can reveal insights into the fundamental nature of reality, insights that are inaccessible to classical computers. For instance, quantum computers could help physicists unravel the mysteries of quantum field theory, the framework that underpins our understanding of particle physics. They could provide new insights into phenomena like quantum entanglement, the Casimir effect, and even the nature of space-time. These discoveries could revolutionize our understanding of the universe, but they could also challenge deeply held assumptions about the nature of existence. Brian Cox has emphasized the philosophical implications of these discoveries. If quantum computers can simulate reality with perfect accuracy, what does that say about our own reality? Could it be that we, too, are living in a simulation created by an advanced civilization with computational power beyond our comprehension? This idea, known as the simulation hypothesis, has been a topic of debate among physicists and philosophers alike. While it remains a speculative concept, advancements in quantum computing bring it closer to the realm of scientific inquiry. But the most immediate impact of quantum computing lies in its potential to reshape the global balance of power. In the past, technological advancements like the steam engine, electricity, and the internet have driven economic growth and shifted geopolitical power. Quantum computing could be the next catalyst for such a shift, with profound implications for global politics. Countries that achieve quantum supremacy will have a significant advantage in areas like cybersecurity, economic forecasting, and military strategy. This has led to a quantum arms race, with nations investing billions of dollars in quantum research and development. The stakes are high, and the competition is fierce. But this race also raises ethical questions about the equitable distribution of quantum technology. Will it be used to benefit humanity as a whole, or will it become a tool for consolidating power and wealth among the few? As we consider these questions, it's important to remember that quantum computing is still in its infancy. Despite the impressive capabilities of Google's new quantum chip, there are still significant challenges to overcome before quantum computers become mainstream. Issues like error correction, scalability, and environmental sustainability remain significant obstacles. Quantum computers are incredibly sensitive to their environment. Even the slightest disturbance, such as a vibration or a temperature shift, can disrupt their function. Temperature fluctuation can cause errors in quantum computations. While researchers have made significant progress in developing error correction algorithms and improving hardware stability, these challenges have not yet been fully resolved. Scalability is another major hurdle. While Google's quantum chip represents a significant step forward, building a large-scale quantum computer with thousands or even millions of qubits remains a daunting task. This will require new materials, new manufacturing techniques, and new ways of thinking about computation. Then there's the issue of sustainability. Quantum computers consume significant amounts of energy, both for maintaining the low temperatures required for their operation and for powering the complex systems that support them. As the world grapples with the challenges of climate change and resource scarcity, the environmental impact of quantum computing must be carefully considered. Despite these obstacles, the potential benefits of quantum computing are too great to ignore. If harnessed responsibly, this technology could transform our world in ways we can't yet imagine. It could help solve some of humanity's greatest challenges, from curing diseases to understanding the origins of the universe. However, achieving this potential will require careful planning, ethical consideration, and a commitment to using this technology for the greater good. Brian Cox's warning about the implications of Google's new quantum chip serves as a wake-up call. It reminds us that while technology has the power to improve our lives, it also has the power to disrupt them. As we stand on the brink of a quantum revolution, we must navigate this new frontier with caution, curiosity, and a commitment to the values that make us human. The future of quantum computing is unwritten, and its story will be shaped by the choices we make today. Will we use this technology to build a better world, or will we allow it to divide us? The answer lies in our hands. Quantum computing is a technological revolution unlike any other in human history. It is not just an upgrade to existing technology, it represents an entirely new way of processing and understanding information. As we delve deeper into this paradigm-shifting innovation, it's important to explore how it intertwines with fields such as biology, environmental science, economics, and even our concept of free will. Let's begin with biology. Quantum computing has already demonstrated its potential in simulating molecular interactions at a level of detail previously thought impossible. Traditional computers struggle to simulate the quantum behavior of even small molecules because the calculations grow exponentially as the molecule's size increases. Quantum computers, however, operate on the same principles that govern these molecular interactions, allowing them to simulate complex molecules with unparalleled accuracy. One of the most promising applications of this capability is in drug discovery. Pharmaceutical companies spend billions of dollars and years of research developing new drugs, much of which is devoted to trial and error processes to identify molecules that will interact with specific proteins in the human body. With quantum computing, researchers can simulate these interactions virtually, dramatically speeding up the process and reducing costs. This means faster development of life-saving medications for diseases like cancer, Alzheimer's, and rare genetic disorders. In addition to drug discovery, quantum computing could revolutionize personalized medicine. By analyzing an individual's unique genetic makeup, quantum algorithms could predict how their body will respond to different treatments. This would enable doctors to design customized treatment plans that maximize effectiveness and minimize side effects, taking healthcare to an entirely new level. But it's not just human biology that stands to benefit. Quantum computing could also help address some of the most pressing environmental challenges of our time. Climate change, for instance, is a complex problem involving countless interacting variables, from atmospheric carbon levels to ocean currents to deforestation. Traditional climate models, while useful, are limited in their ability to account for the full complexity of these interactions. Quantum computers could create hyper-accurate climate models that incorporate far more variables than classical models can handle. These models could help scientists predict the effects of specific actions, such as reforestation or reducing emissions, with far greater precision. Armed with this information, policymakers could make more informed decisions to mitigate climate change and adapt to its effects. Quantum computing could also play a role in developing new materials for renewable energy. For example, researchers are already using quantum simulations to design more efficient solar panels and batteries. By understanding the quantum properties of materials, scientists can engineer solutions that maximize energy capture and storage, accelerating the transition to a sustainable energy future. The economic implications of quantum computing are just as profound. One area where quantum computing could make a significant impact is in financial modeling. The global economy is a complex, interconnected system with countless variables influencing market trends and risks. The global economy is an interconnected system that is constantly evolving. Traditional economic models often rely on simplifying assumptions to make predictions, which can lead to inaccuracies. Quantum computers, with their ability to process vast amounts of data simultaneously, could create far more sophisticated economic models. These models could predict market trends with greater accuracy, helping investors make better decisions and reducing the likelihood of financial crises. Governments could also use these models to develop more effective economic policies, reducing inequality and promoting sustainable growth. However, with great power comes great responsibility. The ability to predict and influence markets also raises ethical concerns. For example, companies with access to quantum-powered financial models could gain an unfair advantage over competitors, leading to a concentration of wealth and power. This is why it is crucial to establish ethical guidelines for the use of quantum computing in finance and other industries. As we've seen, the applications of quantum computing are virtually limitless, but as Brian Cox has warned, this power also comes with significant risks. One of the most concerning aspects of quantum computing is its potential to disrupt the balance of power on a global scale. Historically, technological advancements have often been accompanied by shifts in geopolitical power. The invention of the steam engine and the Industrial Revolution propelled Britain to global dominance in the 19th century. The development of nuclear weapons during World War II established the United States and the Soviet Union as superpowers. Now, quantum computing could spark a new kind of arms race, with nations vying for quantum supremacy. The country that first achieves full-scale quantum computing could gain a significant advantage in areas like cybersecurity, intelligence gathering, and military strategy. For example, a quantum computer could decrypt encrypted communications in real time, giving its operator a clear advantage in espionage and counterintelligence. This could lead to an era of heightened mistrust and competition among nations, as each seeks to protect its own interests and outmaneuver its rivals. To prevent these risks, it is essential to establish international agreements on the use of quantum technology. Just as treaties like the Nuclear Non-Proliferation Treaty have helped limit the spread of nuclear weapons, similar agreements could ensure that quantum computing is used responsibly and for the benefit of all humanity. Beyond the practical implications of quantum computing, there are also profound philosophical questions to consider. One of the most intriguing aspects of quantum mechanics is its challenge to our understanding of reality itself. The principles of superposition and entanglement suggest that particles can exist in multiple states simultaneously, and that the state of one particle can instantaneously affect the state of another, even if they are light years apart. These phenomena have led some scientists and philosophers to question the very nature of reality. Are we living in a deterministic universe where every event is the inevitable result of prior causes, or is reality fundamentally probabilistic? Does the act of observation truly determine the state of a particle, as some interpretations of quantum mechanics suggest? If so, what does this mean for our understanding of consciousness and free will? Brian Cox has often spoken about the philosophical implications of quantum mechanics, describing it as a window into the fundamental workings of the universe. The advent of quantum computing could provide new insights into these questions, offering a deeper understanding of the nature of existence. For example, quantum simulations could help test different interpretations of quantum mechanics, such as the many worlds interpretation, which suggests that every possible outcome of a quantum event occurs in a separate parallel universe. If the many worlds interpretation is correct, it raises even more profound questions. There are countless versions of ourselves living out different lives in parallel universes. If so, what does this mean for our sense of identity and our understanding of morality? These are not just abstract questions, they have real implications for how we view ourselves and our place in the cosmos. In addition to challenging our understanding of reality, quantum computing also forces us to confront ethical questions about the use of technology. As we've seen, quantum computers have the potential to solve some of humanity's greatest challenges, but they also pose significant risks. How do we ensure that this technology is used responsibly? Who gets to decide how it is developed and deployed? How do we balance the pursuit of innovation with the need to protect individual rights and societal values? These questions are not easy to answer, but they are essential to consider as we move forward into the quantum age. One possible solution is to establish a global framework for the development and use of quantum computing, similar to the frameworks that govern other areas of science and technology. This framework could include ethical guidelines, transparency requirements, and mechanisms for accountability will be essential in ensuring that quantum computing is used for the benefit of all. Without these safeguards, the immense power of this technology could be misused, leading to unintended consequences that could deepen inequalities and create new risks. As we reflect on the implications of quantum computing, it is clear that we are standing at a crossroads. The choices we make today will shape the future of this technology and its impact on humanity. Will we use quantum computing to build a better world, solving some of the most pressing challenges we face? Or will we allow it to widen existing disparities and introduce unforeseen dangers? The answer depends on our ability to navigate this new frontier with wisdom, foresight, and a commitment to the greater good. Brian Cox's warning about Google's quantum chip is a call to action, a reminder that the power of quantum computing comes with great responsibility. It is up to all of us, as individuals and as a society, to ensure that this technology is developed and deployed in ways that align with our values and aspirations. The future of quantum computing is unwritten, and its story will be shaped by the choices we make today. Let's make sure it is a story we can be proud of.